Okay, so hello everyone. I am Lara and I'll be there as a tech support during the tutorial. I want to introduce you to our tutor, Mikhail Rozhkov. He's a solution ML engineer at Iterative AI, and he will hold the build end-to-end MLOps platform with open source DVC ecosystem tutorials. Enjoy it.
Yes, hello everyone. Hello everyone. My name is Mikhail. Yes, and today we'll talk about MLOps, about open source tools, about DVC tools, of course. Yes, but before we start, let's know each other a little bit and test that everything works fine, that you can, I don't know, post something to the chat and I can see it. So if there are any questions, I'll see them and can answer. So can you like first start with just type your name, I don't know, and what are you doing, what your role and or ML application that you are working on? I just want to see that everything works fine before we start. Okay, let me then share the screen and we start. Okay, unfortunately, chat is deactivated. Unfortunately, it's not what I was expected, to be honest. Yeah, because this should be like interactive tutorial. Okay, give me a second. There's some technical issues.
Okay, so unfortunately, I cannot activate the chat, but people can ask like a question, so they can maybe introduce themselves as a question. I'm sorry for the
no, it's not a problem.
So
yeah, it's not a problem. If we can use Q&A, right? We can use Q&A
yeah.
tool. Yes. So yeah. Okay. If you have questions or you wanted to share something, please use it. Yeah. Okay. Let's start. Let's start anyway. Let me share the screen with you. Oops. I'm sorry, I need to reopen, quit and reopen the Zoom. I'm sorry for this delay. Hello everyone again. Hopefully everything is fine and you can see my screen. Okay.
So can just everyone confirm that you can see the screen, because so that we know that everything is okay.
Yeah.
Okay.
Cool. Yeah, cool. Thank you very much. Okay, let's finally begin. My name is Mikhail Rozhkov, and we'll talk about building open MLOps platform using open source tools and using DVC, of course. And yeah, I'll share the link to the materials after the as soon along the presentation. So no need to do anything else right now. So we'll do it step by step. Let me first introduce myself. As I said, my name is Mikhail. I got my major degree in marketing. So I'm not a technical guy originally, but later I had a chance to go to get PhD in Hong Kong. I studied at Polytechnic University, and there I started to learn data mining and programming and do data analysis for my thesis. And this is how I came into data science field and started to do data science and machine learning development. So, and I was started like with data science, like as a job in 2016 with NLP problems and Kubernetes stuff. So we were building some search engine using neural networks and trying to launch everything using Kubernetes. And after that, I joined Raiffeisen Bank as a senior data scientist, and then I spent a few years in the banking doing different data science projects. And at that time, actually, we realized that we need to have tools to manage complexity of data science projects, to do some kind of automation and versioning and to build reproducibility in projects. And this is how we started ML Repo community. So this is a community about good engineering practices, reproducibility and automation for machine learning. And with this community, actually, we run some online meetups from time to time and share some insights and how to work with different tools. And also, I designed a couple of courses about MLOps and how to build MLOps platform with DVC. So actually, with the main open source tools for experiments tracking, automation, and some scheduling. And also, right now, I'm working as a solutions MLOps engineer at Iterative AI. I help teams who use DVC tools to integrate them into their use cases into their projects. And yeah, so this is why actually this talk is about DVC tools, because like Iterative is a company that develops DVC. Yeah, and also personally, I'm interested in different kinds of automation and like dreaming about tools that will help machine learning engineers and developers to build AI systems and products faster. And yeah, and as much automated and robust as it possible, actually. So that's why we are talking about DVC, because DVC brought a lot of good engineering practices into data and machine learning workflows. And like DVC as a core product of Iterative focuses on versioning ML projects, like including data, pipelines, experiment results, do tracking and visualization of experiments outputs, and also automate pipelines. So this is a core open source product that we have and developed for around 5 years already. And because this is open source and most common line interface, it can be quite difficult to use this tool to scale and use in the teams, because like for collaboration, you usually need to have some interface where you can share experiment results with colleagues, iterate on them, do some kind of, I don't know, visualizations and model management. And this is how we started with DVC Studio, Iterative Studio, like previous name. And this is like place where we collaborate with the team, and this is our commercial product. And everything's fine. Everything was fine till the time when generative AI became very important and like as a mainstream, and we realized that DVC functionality is limited to some small and medium-sized data sets, and we need some tool that will optimize pipelines and machine learning workflows for large scales of data, for millions and billions files, for images and text that can like help and support actually teams developing generative AI solutions. So this is how we came up to DVCX. This is a new tool we are working on and almost ready to release it, that will focus on unstructured data management and dataset curation, and will also provide that versioning stuff and as a DVC, as a regional DVC, but will able to scale to billions of files and remove some problems that DVC has at the beginning. So we are working on those tools as a company, and today we'll focus on like some basics of DVC tools and some conceptual overview of MLOps architectures, patterns, and how you can actually start with DVC and understand what is the best fit of different DVC tools into your project, into your pipelines. So yeah, and before we start, actually, it would be cool if you can share any ideas about like your expectations, what you're interested in regarding this topic, regarding MLOps, regarding DVC. So if you can share your questions and expectation in the Q&A channel, so it would be helpful and will help us to focus on some specific points that you are interested in. So please do it, please do it. And we'll work today in more interactive way, as much as we can using this Q&A channel. But what is our goal? So actually our goal is not just take some example and guide you how to run commands one by one to get some results, right? So because you can easily do it with like examples we'll use during this session. So by own, and later, I don't know, ask questions if you have. We'll have examples, but this is not the primary goal. Our goal is to understand some approaches how to design a MLOps platform for your team, for your company. What are requirements and what tools you can use. And of course, what is the best place for DVC tools in this ecosystem. We'll focus, of course, on GitOps approach, how it works, why we need it, and how DVC actually helps with it, and look for some examples. But the second important goal for today is to know each other and like start collaboration and start talking to each other to discuss things, because like there is no ideal solution on the market, there is no ideal tools, and but there are some workarounds, different kinds of integrations that we can provide, and like people share in the community, in the DVC community, that we designed for our clients, and we are happy to share this. So if we'll know each other and we can talk during the conference or after that. So let's know each other and learn from each other to be more successful in the future. Okay. So there are also a couple of questions we can discuss later, or maybe during the Q&A session later, is how to do some kind of integrations, how to run distributed pipelines with DVC and other frameworks, and what best practices for CI/CD, etc., etc. But like, let's do it step by step. Okay, I see that Someone interested in the model deployment part? Yes, and we'll have that part, of course, today. We'll discuss it. So yeah, thank you for your sharing. And yeah, if you have any questions during the presentation, please feel free to ask me. Okay, let's start with MLOps. Patterns and architectures and what is MLOps. So no big I don't know, big concepts. And what is MLOps actually? We'll follow this definition that this is a set of standardized processes and technologies that help us to build and operationalize machine learning systems rapidly and reliably. And like no magic, just good engineering practices and good collaboration practices around developing machine learning models and applying them into some products and processes. That's it. But there are a lot of different tools, yeah, that we know that people develop for MLOps that we can integrate. I have experience maybe with 1/3 of them, maybe 1/2 maximum. But yeah, for different projects, like different stack of these tools can be like more preferred than others. Anyway, in most of the any use cases in machine learning and AI development, we have 4 main processes that we should care about: is data engineering, machine learning engineering, application or inference engineering, and monitoring. Right. So no matter what kind of machine learning applications you have, batch scoring for banking or telecom or retail, or computer vision or NLP or generative AI, it doesn't matter actually. So at any product you have data engineering. After that, you need to develop some kind of model or tune some model and run that model to generate predictions. And as soon as you do it, you need to understand what happens with the system that generate predictions and what quality data you ingest into the system. So the monitoring helps us to understand what is happening inside, right? So we can simplify simplify this and rename, rephrase it into pipelines. If we have some project, we usually have some data pipeline that prepare our data set, right? Maybe split it into test and train and test data sets. For table data, it's some kind of, it can include some different transformation and feature engineering steps, and transformation some data into the target variable for model training. For computer vision, it's actually the same, but as a result, we have the data sets and some annotations for the data sets. And these are the data sets we just goes as input into the training pipeline. So on the conceptual level, on the high level, it's they're pretty the same. So we can jump inside and see that a lot of different technologies for training, like inside of each of these blocks. Every company that sell you the tools, promote their tools, they develop can make this diagram more complex and to prove that you need to follow some specific practices and use specific tools because of one, two, three, some reasons behind that. But in general, this everything's pretty simple. And we'll try to keep this as simple as possible. And we'll consider today only 2 patterns that you can we often see in different teams. Again, in different applications, no matter what data people have, it can be like tabular data or images or videos. So first pattern is the monolithic pipeline that inside can do feature calculation steps, model training, and prediction. And depending on some like argument that you use to run this command, this pipeline can behave as a model training in model training mode or inference mode, right? So we just can pass that mode argument to the our Python model, and like inside of that model, you'll see that the logic will just switch between that model training or predicting. Anyway, when you run it, as a result, we have some predictions stored in predictions database or data storage. There are some model that we can save outside and keep for later use or for history, whatever. And after we have predictions, and after we collect ground truth data, some labels, whatever, we can actually calculate some model monitoring metrics and understand that model like works as expected. And of course, like monitoring can be extended to the data validation task, etc., etc. So it's like a lot of tasks can be inside this monitoring. But the idea here, like, what is the easiest part? And usually, like, people start with such kind of monolithic pipelines. These pipelines you can find inside Jupyter notebooks, right? When you like people iterate and do prototypes with for new tasks, they usually create a huge Jupyter notebook with all steps inside, from data preparation to model training and generating predictions. So this is like first solution. Then this code can be just moved into the Python scripts, and you can run everything like using such kind of Python models. And everything is fine until some level of complexity of the code inside, and resources of time and computation resources that you need to run the whole pipeline. Because, for example, just imagine that the training pipeline takes a few days to run from the beginning to the get model, and I don't know, at the middle of this pipeline you get some error and the process stops. So you waste, I don't know, a couple of days of running your pipeline on GPU. You need to fix some bug and rerun the model, run the pipeline again, and you'll do the same calculation for features or some data pre-processing, and then multiple of epochs and iterations, right? So this is not very good scalable solution. It works, it's simple to start, but at some point you need to update it. And the next step, what people do, they just split this monolithic pipeline into a separate pipelines of stages. We can talk about pipeline stages is like in the interchangeable topics of synonyms here, so it doesn't matter. So idea, we can wrap every steps that do some kind of computations and have some outputs as an independent module. This will give us like multiple improvements and like benefits. First, you can run every of these steps like separately, and when you run this step, like you understand that the behavior of these steps and what this step should produce, what inputs and what outputs we have for this step. So we can independently develop every steps, or even use ask different teams to develop each part. Data engineers will develop data pipeline, for example. Data scientists will develop model training, right? And software engineers can just wrap everything into the inference pipeline and write these inference pipelines script, something like that. The only requirements here that we have is to have some kind of interfaces between steps. So if model training expects to have data and features in specific format, that like this is a requirement, the only requirement for data pipeline to prepare the data sets. The same for inference pipeline. If we, I don't know, run our model for online inference pipeline that has some limits for RAM and model size. So this is a like input requirements for the model training pipeline and for data scientists. So please, don't use huge neural networks for simple and fast inference pipeline. Just used like lightweight XGBoost or linear regression, something like that. So dependent on that applications and requirements of from the business perspective, from the infrastructure perspective, like you can adjust the interfaces or like protocols that guide people that developing different steps for such kind of system. So this is more flexible, right? And people can even change the Python to some technologies between the stages. So they can start with Python, that they can switch to, Rust or Scala or whatever for data engineering, for example, etc., etc. So we have the modular system. It's more flexible. We can scale it. We can like iterate faster, and we even as soon as we did this separation, we can even independently scale every step separately. So we can, for example, run data, process it on the CPU machines, or one machine or multiple, and then we can run our training using the GPU machines in different clusters, so distributed. So all this flexibility we get as soon as we have such kind of modular system. The inference pipeline here usually contain the code that load model, load data, and just run some kind of service that to generate predictions. For batch scoring, it can be just apply the downloaded data set to model and get some table of with prediction and save it as a file, or save the results into some database, right? For online predictions where we need fast response, we can wrap this inference pipeline. We can use some fast API or Flask, for example, to build web service that will handle requests with new data and will respond with predictions. Or we can use some streaming solution. So for inference pipeline, on the conceptual level, we just need to take the model, right? Download the model, wrap it in some code that will take this model and generate prediction for new data, and we need to run it somewhere. So and this inference pipeline actually depends on that kind of application data use in the company. So nothing specific inside, it depends totally on your examples and your business requirements. However, so what we can summarize here is some kind of principles that we can follow, and that will help us to design beta platforms for all parties who are involved into this machine learning development cycle. Data scientists, data engineers, software engineers, and different stakeholders and product managers. So first, research friendly, because most of our work with people in AI is based on the research, right? This is research first field of engineering. So we need to make tools and this platform friendly to researchers, for data scientists who may not have deep engineering practices, and they prefer maybe using Jupyter notebooks and have visual interfaces. But and like even if we want to follow like good engineering practices and GitOps approaches, so we can make this platform as friendly as possible using different kind of templates by hiding some complexity and engineering complexity under some user-friendly API that data scientists can just use, and using some simple interfaces between those steps. So, for example, like as output of the training stage, we can like require to have model in specific format wrapped into, I don't know, specific data format like ONNX, for example, for neural networks, or yeah, something like that. And so some minimum requirements that researchers need to follow to simplify that adoption of their results into their the next steps, like inference, for example. So second principle is versioning and reproducibility. Small projects, it's not a requirement. It's not a requirement for prototypes, but for production projects, and especially in the field when we need, there are some like high cost for some risky. Okay, when we can have like high cost for biased or biased predictions or some misbehavior of ML system, we need to ensure reproducibility inside. And versioning is the first step to ensure reproducibility. So we should version the code, of course. We can version data. We should version like all configuration parameters that we use to run this model, and the results, of course. The next one is modularity and flexibility. This is what we already discussed, right? As soon as we have modularity, flexibility, we can wrap the system into something scalable. We can call the different stages in our pipeline on local machine, or we can use, for example, Ray to run the same code on the cluster by defining the different resources we need, including CPU, GPU, whatever, and yeah, and like make it faster and make it more efficient. And after that, we should, like, of course, monitor and do some kind of data governance. And all of this, like, complex stuff requires like, GitOps approach to make it reliable and robust on the production. So we version everything with Git. We can use CI/CD pipelines to control the life cycle of our projects, when to run like the model to production, when to update model in production, etc., etc. So this is more engineering part, and different like principles actually focus on different people. So research friendly reproducibility is appealed to a data scientist. Modularity, scalability is more about software engineering part, but of course this kind of principle should like ensures that the research friendliness for people, and the GitOps is for DevOps, of course. So why is GitOps? First, it ensures and helps to build reproducibility, and it like it uses your Git repositories as a single source of truth for your project. So whenever you ask people what version of actually how they get the specific model, or what the model in production like behave unexpectedly. So what code was used to generate this model, what parameters were used, etc., etc. So like Git and CI/CD pipelines helps us to answer these questions. And to make it work, actually, we should use Git. We may use like some tools for that helps to use infrastructure as a code, like a Terraform. And we also should follow the same principles for data and model lifecycle. And this is where DVC tools helps to ML and AI developers to bring this GitOps approach to machine learning projects. So we are ready to go to the next step. If you have any questions, please ask in the Q&A channel. And we start with data versioning. So what is DVC? DVC, or data version control tool, is a tool that provides three main functionality. First is data versioning. So you can take some data file, and DVC can help you to manage what versions of this data set you have in the project. You can save new versions, you can change versions in your project. DVC can save versions, upload them that version to clouds, for example, then bring it back, etc., etc. And it can do this for any files like data and models. And this is how it can help at the different steps of the pipeline. The second one is pipelines automation. So with DVC, you can easily configure what order you want to have in your project and how you want to run your experiments, like from, I don't know, the data preprocessing till the model evaluation. And like experiments management. DVC can track all outputs and metrics and plots for your experiments. The studio as a next step is a collaboration tool. Gives additionally data management, like experiment management, that collaboration functionality and model registry for DVC ecosystem. But the focus today is for DVC, and what I want actually is to help you to understand that the core concept and principles of DVC, how DVC works. Because even if you know only that principles and understand how DVC works, you will have you'll have enough knowledge to understand how you may how DVC can benefit your project, and how you can implement it, and what other tools from DVC ecosystem you can utilize in your project. So let's start with DVC. I expect that you have some knowledge about Git, and you know that how Git works to deal with code versioning, right? So and here I want to just show this analogy that DVC uses Git to handle data versions in the similar manner. So let's start with our project on the local machine. So we have some local repository, Git repository, where we have different versions of code and some files. So at the same repository, when you work with DVC creates some metadata about when DVC versions some data, it put it in some local cache, and locally you have separate repository for your code, right? And DVC put files in some local cache. So this is local work for with DVC. So you have code, you have locally something, some data files, and to add, for example, new changes, new versions to the Git, we use git add and git commit. With DVC, it's very simple, similar. It's DVC add command. We can use this command to add some file to under the DVC version control, and DVC will generate some metadata that we put into the Git repository. But keeping that model file itself separately in the cache directory. So, and the next step, when we want to collaborate with people and persist results, we use remote repositories. So with the Git repository, we use GitLab, GitHub, or some other system, and we just do git push to synchronize our local results with a remote repository, right? And the same we can do with DVC. So we can ask DVC, do DVC push to save local file to some remote storage. There's like two main operations with DVC that like you need to start. To DVC add some file to the under DVC control, and DVC push to upload it to remote storage. When you need this file back, you'll just do DVC pull command, and DVC will download that file back to your project. Okay, so how like DVC works with data? So like first thing that the interface for DVC is very similar to Git, right? Git add, DVC add, we save some changes. With git push, git pull, like you synchronize your Git repository with GitLab, GitHub, and you can do the same with DVC. One note here that DVC works only with the data stored in files. So if you want to version something with DVC, the data should be in some kind of file. So it works best with texts, images, of course, or table data that's stored in CSV or Parquet formats, something like that, when they're in files. And in this case, yes, you can version them with DVC, and of course, any kind of machine learning models. And if you have your data inside database, then like DVC doesn't have instruments to do some kind of queries and to version queries. So, and here can be like a couple of workarounds. First, if you like ensure that your queries are reproducible, so every time you run query, you can get the same slice of the data. So the first option is just to keep this query inside your Git repository and version is with Git, and it's enough to ensure reproducibility in terms of like data use for the you generate for the project. Another option, sometimes like the queries takes a lot of time to run, to extract data from multiple sources, do some kind of joins, and use the results, for example. So, for example, you have a local query to collect the data from different sources and generate, do some feature calculations for your project. And then you can save the results into some data mart for the later use, or you can save results of this features into some file format and version them with DVC. So again, in different situation, it can be like you may prefer different approach. In terms of size limitation, there is like no size limitation in terms of files. So files can be like pretty large. It's not a problem for DVC, and DVC works better with a number of files below 100,000. So more than 100,000 files can like slow down DVC operations, because like every time DVC run, it checks the versions of the files. I'll explain how it works later. But like there is no limitations in terms of like size of the data file, but there are some limitation when you have a huge number of separate files. And this is why like we are developing like new DVCX tool that will handle that huge number of files itself. Okay, so like what DVC does, it just takes your data and move it to the remote storage, and saving your repository only some metadata with .dvc extension that contains information about the data set itself. So if we look inside, actually, so inside that file, we can see it later. It's just some kind of like hashes that that kind of pointers to that version of the file. So, and by saving this metadata to the Git repository, like DVC, DVC creates this link between the Git repository and data storage that you use to store your data. And you can do like different kind of synchronization and switching between versions using this metadata. Okay, actually, we can start with some kind of example just to make sure that this part is more or less clear for us. Okay, so actually what we can do, yeah, we can use this example. So I share to the chat. So this is basic example for DVC, and we can start to use it for our projects.
Sorry, you just have to change that when you send that message to everyone, because here it says host and panelists, and then
yes, okay, yeah. Yes, thank you very much. Okay, here's a link. Here's a link. Okay, let me just if you want to follow me, so please take this link and yeah, let's do. Just clone the repository. Okay, we navigate to the repository and open the code in some IDE. Use VSCode extension. And here are some okay. Yeah. So let's do it. Let's do it. And if you open like README, here's a couple of like commands that how to prepare that environment in the README. So we create first create the virtual environment. I'll use VM to do this. Okay, then we activate the environment and install the requirements for this project. So this will install. It will take time to install the dependencies, but we can start with another project just using the command line interface. Just with like some basics of like DVC, actually, how to start it. Let's create, like, to start with working with DVC, what we need, the main requirements is Git repository. So we can create a new project, call it DSC demo, for example. Navigate to there and initiate Git. Using Git init, we create Git repository. Okay, so we have a Git repository. There is nothing inside, and what we can do, like to create DVC projects, what we can do? We actually should. Yeah. Also, please let me know if you you have some. If you need to like enlarge texts on the screen or whatever. Okay. So to create DVC product, you should first do install DVC. So do some kind of pip install DVC, or let's start with creating virtual environment first. I like to use Python vend. So we create environment, we activate it in our terminal session, and then we can install DVC using pip install DVC. That's it. So it will take just a minute. Yeah, it's almost done. Okay. What we have now inside our repository, we have just git at .env directories that we use to install all dependencies, including DVC. And now we can start with DVC. So to start it, we need to run command DVC init. This command initialize the DVC project. We can use -v argument, I guess, to show more logs here. Let's do it. And we see that it's pretty fast, actually. What DVC does here, it creates a new .dvc directory inside your Git repository. And if we'll navigate to the directory, so inside we see that there is some kind of config file, which is empty, and some TMP subdirectory that is also empty. But if we check Git status, we see that like DVC after initialization ask us to add these changes to the Git repository, and this is what we should do. So we do git commit and initialize DVC. So this is all we need to start with DVC. So after this, you have like you can start versioning your data set. What we can do here. So let's create some file txt, empty file, and if we check DVC git status, git see that this file is like added to the project repository, and you can add this file to under control of Git, or if this file like huge and this is data file, you can want to version it with DVC. What we want to version it with DVC, and for this we only need this DVC add and specify location of the file. So DVC add file.txt. So we'll see that here's like the bar with the status of the files added to DVC control. For example, if you will want to add the whole directory under DVC control, you will see that this bar will like updating like through time, and you can control the number of files added and the speed of files, etc., etc. And automatically DVC like creates those .dvc the file with .dvc extension to your Git repository and like add them to the Git index. So let's check Git status again. we see that we have this git ignore and file txt inside. So what DVC does? First, it adds this like file with DVC extension. Let's look inside. And inside we see just a couple of fields. First is MD5 hash. That is DVC uses as a pointer to a version of this file, to this original files.txt, the size, type of hash used, and the original path. That's it. And what we need to add this file with .dvc extension and git ignore to the git and comment. I use some kind of aliases to speed up the process. So here is just commit, and this is a git status. So by doing this, actually, we just committed the first version of the file to DVC with DVC. So file is stored in DVC cache. So we can actually navigate, look inside those .dvc directory that was created at in this initialization step, right? It was empty. Now we have like more files in TMP directory, so different technical log files that we don't need at all. But here inside we see that we have the cache subdirectory with the files, and we have the new file, like one entry inside. If we look into that, the format of this entry, you can see that first two symbols in calculated MD5 hash or in our metadata file is used to name the directory under this inside this DVC cache storage, and the later part of this MD5 hash is used to name the file itself. So this is actually how DVC stores data inside cache storage or remote storage or whatever. It uses this MD5 hash to understand what how to locate the file in the storage. So what we can do now, for example, we can remove the file txt from our repository. So let's check that inside repository we don't have the file txt at all. And using DVC checkout, we can restore this file and see that like DVC downloaded this file from the cache directory where it was stored. Okay, so this is actually how it works. If you want to add some files to under DVC version control, it put the file itself into the cache directory and create inside your Git repository this metadata file. That's it. And by switching between commit branches versions inside your Git repository, you can update the state of your file, like ask DVC actually to download that some required version of this file into your workspace. What we can do next, we can create a new branch, check out new branch, and let's call it version 2. And we can do like add some like text into our file txt. So it was empty at the first for the first version, right? So we can add some line inside. So let's check that we have this line inside this file. yeah, it's there. We can check, like usually when we do some changes inside Git repository, so Git see those results, right? So we can check Git status, but Git don't see the changes in the files that are under control of DVC. Why? Because when we add the file under DVC control, it it just adds a new like entry to the git ignore. So adds this file to the git ignore to exclude this from the git version control, and only and git will control only this file txt DVC. So if we check the DVC status instead, so DVC will detect that this original file txt has changed. Okay, so what can we do? Here we have like two options. First, we can use DVC to unroll these changes. So we can use DVC checkout again. Okay, comparing indexes, forces. Yeah. This is good point. Like inside DVC, there are different like kind of like different mechanism to prevent like some changes, unwanted changes. So, and if you like DVC see that like some commands can break change files and that cannot be like restored, it asks you to do some kind of force. So we can do force here, just and see that like DVC like just look inside the file, and right now the file .txt is empty. So because DVC just took the version that associated with the metadata in this workspace, found this version in the cache directory, and bring that version back. So if we want to change and save these results to like save new version of that file .txt, let's do it again. So we can do it like like create this new line inside this file. So let's check that we have this line inside, and now we need to do DVC commit command. So in this case, like DVC create like new updates that metadata for this file. This DVC file. So it now for this file, we see that MD5 has changed. That like now we have size 9 kilobytes. Yeah, and we also can like look inside our DVC .dvc subdirectory and see that now we have like 2 files inside the cache. So after we do this DVC commit command, so it creates like new metadata for the new version of file, and yeah, and now like Git will see that there is updates for this metadata file, and we need to commit like to the Git repository that we have like a new version of the data file. What's happened? Okay, yeah, we need to add this file first and then commit it, of course. Yeah, so now in this version 2 branch, we just updated our data file and committed with Git. So what can we do next? The next step, we can like, right now we have 2 versions of file saved in different Git branches. Now we can just check out into the first branch, into our main. Okay, it's master. Okay, get checkout master branch. And we like right now we should have not original file, but the second version of file for our DVC file. Oh no, not for the data file. We see that for metadata file we have like metadata that committed to the master branch. So this is original version of the file, but the file itself is like contains some data. So this is a second version. So what we need to do is do DVC checkout. So when you like, okay, and this will like DVC will update the file in our workspace to the version that is associated with the metadata for this Git revision. So inside Git, we have different commits, different revision of this metadata file. As soon as we like switch to a specific version of the workspace, we can ask DVC to update the data files under DVC control in our workspace, and we do it with DVC checkout. So if you want, this helps us to switch between versions. We just do git checkout to specific Git revision, and then do DVC checkout to update our files for this Git version. Okay, so this is how DVC works, and this is how like what you the minimum use case that you can minimum functionality that can help you to deal with some features, data files with features. For example, if you want to track versions of them, you can track model files. Just add them to DVC control and like save these versions with data. Actually, right now it seems like too many commands. They can be automated. There are some Git hooks that will, for example, update like do these DVC operations automatically when you do Git commit and Git push, for example, for every model files. So the workflow can be much easier, actually. Yeah, but it for example, already allows you to track versions of different versions of your models, at least. What else you can do with DVC? Also, you can, for example, like when you add these files to version files with DVC, DVC also can like help you to download these files from this project into another project. For example, there is such kind of concept that called dataset registry. Oh, sorry. Give me a second. I just want to copy this link. Yeah, this one. There is a concept of DVC dataset registry that shows how you can reuse datasets between different projects. So in this case, we have example that repository that contains metadata about datasets used in different tutorials, examples, etc. It's like following the similar approach that we just used. We took some datasets and directories, versioned them with DVC. Like in this case, it was a directory, and like uploaded that, like synchronized that data with remote storage on S3, for example, and keep this metadata in this separate repository. And actually, this helps us to reuse these data sets in different projects. For example, here inside like this get started, we have this data XML .dvc metadata. So this is also like large files, like pretty large file that we can reuse. And for this, we can use DVC get command. So DVC get, then we specify the path to the this repository, and then specify location of the file inside. So here, like the directory get started, data file, and but not the like with .dvc extension, but just original one, and the outputs where we want to save this file, and we can just run it. So, and under the hood, DVC will clone this repository, like parse it, will find the information about this data set, and will save this data set under that data directory. So we can look inside. Okay, and see a lot of text. So actually, it's the XML files. So this is example actually how you can reuse data sets between different projects. It can be handy, for example, if you have some not very dynamic data sets that different teams are using for their experiments. And for example, when it takes a lot of time to prepare data sets and process them before training, so you can have a separate pipeline that do this data processing, data management stuff, data processing transformation, I mean, and like save and version results of that data pipeline to keep the version of data sets here, like in separate repository, and other people can just download it. Or if like this is not like you don't need specific a separate actual repository to keep this data set. For example, if this this repository for your project, for example, the project where we use build the model to do some kind of text classification based on this .xml data XML file. So and inside we have like just code. So this data version with DVC and just code for this project. Anyway, like people from other projects can just download this data using this DVC command. So and inside this the first example repository that I showed you, so we have the same like the same examples for similar concepts, similar use cases. So let me just make it a bit too much. It's a bit bigger. Okay, so let's. Okay, so okay, to make it work actually, right? So we keep this metadata here in the repository, but data itself we put into some remote storage into S3 bucket, and we run this DVC get command. So DVC actually download the metadata from the Git repository, right? But it takes needs some way to understand where the original data is stored and download it from there. Okay, so we can navigate back to this dataset registry that we used and jump into this .dvc directory. And here we need this config file. So inside this config file, we see the couple of remote storages. So this is actually just location of files of the storages for our files. It can be just HTTPS. Like usually we use some S3 buckets or some GCP storages to keep our data inside. It can be like DVC supports multiple protocols, including HTTPS. But the most used most common use case is to using some buckets in common clouds to keep this data. And to create these storages, you can run a command like DVC remote add, right, and add the storage for your data. Or you can, for example, for this example get started, we can check the DVC remote list, and it will show that the name of remote storage and the location URI for this remote storage that DVC used to load to keep data. And for example, for this project, we can use DVC pull command to download the data from the storage to our local machine, to our workspace for the next experimentation. So it will take some time, but it will bring the same version of data set that I use to run this example. Okay, so this is like how DVC help teams with data versioning. So you can easily, your colleagues actually can easily clone the project and use a DVC pull command to restore all data models and other artifacts required by the project. So what else? What else? I see a couple of questions. The first question is DVC Python specific? DVC like written on Python, but like it's a command line tool, right? So you can use it in like with any, I don't know, any kind of technologies and projects you like. So your code can be in C, R, whatever. You just use this command line interface to deal with data, And then another functionality that is pipelines. It also can work with different projects. So there is no actually some Python like strict binding to the Python ecosystem. It can be used with R, of course. It can be used with R. Okay, so I guess that's it about data versioning, like the simple like manual way to version data. And we can go to the next topics. If you have any questions, so please let us know in Q&A session. We go to pipelines, right? So data version is fine, is a like good start for our data pipelines to version the outputs of data pipeline. It's not necessary and not requirement for every project, but it's like quite common use case. Let's start with another pipeline tools. And first is the functionality is the pipelines, ML pipelines. When we start to with experiments, usually we have some prototypes in Jupyter notebooks, right? It's easy to use, easy to visualize results and iterate on projects, but it's not easy when you want to collaborate with other people on that project. If it like collab in a shared folder, right, and people like use the same file to run every time. So maybe like it's some kind of workaround. But if every data scientist uses with his own copy of notebooks, and from time to time you need to share results, so it's a bit messy, and it's often use case when you cannot like reproduce results of your colleague, for example, because of different dependencies, because of on the Python level, on the system level, and it's difficult to like reproduce, right? But they're very handy tool. I'm sorry, just wanted to, I saw the couple of more questions. First is about the DVC. Just complete them and go to the next steps. About like DVC, is it hosted or there are kind of licenses? Okay, so DVC itself, DVC is an open source tool. that you just can install using pip, right, as any other Python package, and use it for on your local machine in cloud environments, whatever. So it's free, it's open source, and it's easy to use, I would say. Not everyone agree with me. It can be some. It will require, of course, some learning curve, but in general, it's for most use cases, it's pretty easy actually to start with, and it's free. Just install and use it. Okay, and okay, at the iterative side, we have only one commercial product is Studio, DVC Studio, that is can be installed locally on premise or but originally is a SaaS software. It can be clouded in hosted in your cloud infrastructure, whatever. But that this is a separate product. So under the concept is that we build open source tools for different purposes, and on top of those tools, we just build that collaboration platform, DVC Studio, that helps team collaborate on the scale, right? But for a separate project for individual researchers and engineers, so our tools have the open source version and you can use it. Okay, and if you want to, another question, if you want to synchronize DVC and Git branches, you can use some Git hooks just to in DVC documentation. There are Git hooks that can automate these operations. So you do Git checkout, DVC will automatically update the version of datasets, and the same with push-pull hooks, something like that. So you can automate this. Okay, let's come back to the pipelines. This is a pretty big topic as well, but we'll try to make it easier. So Jupyter Notebooks, easy tool, interactive, with good visualization, but not really good for MLOps. You can, of course, run the whole Jupyter Notebooks in production and generate results, but it requires just some practices to make it reproducible and well-structured. It's possible, of course, but it just requires you to treat Jupyter Notebook itself not as a tool for prototyping and interactive development where you can, I don't know, run cells in different order, but you need to treat it as a script that you need to run from top to the bottom, and at the end it will generate some kind of results, models, whatever. But anyway, it's possible. We even have some example of integration using DVC with Jupyter Notebooks. So DVC is used to run Jupyter Notebooks to generate, to train models, and after that it version the model, the output from this notebooks. So, pretty flexible functionality. Okay, what is a pipeline in DVC? So we can start with Jupyter Notebooks with a single one where we have the all steps for data processing, training, and evaluation, or they can be split it in different Jupyter Notebooks, whatever. But at some point of development of your project, to make it more reliable and automated, we can wrap your code in some Python or some scripts. For example, it's Python modules or R modules, whatever. So it can be any languages. Idea is that we can just we split our code into separate scripts that we can run independently, and then we'll need to some way to automate the order to run these steps. So we should first load data and do some kind of data transformation before we train and evaluate, right? And there are some kind of dependencies between these stages. So data sets, like a data split, we have trained test data sets. So we should use train data set for the training and test for the evaluation. And DVC actually helps to easily configure the order of the steps and dependencies between them. So how it works? DVC has this dvc.yaml file. This is a simple YAML format configuration where we have different stages. In this case, it's data load, data split, train, and evaluate. And for each stage, we have we have some command that we need to run for this stage. Again, in this example on this slide, it's a Python script. It can be R script. It can be any other language, or it can be like pure shell script code here. So it doesn't matter. So idea that every step has some command. It has some dependencies and parameters and outputs. And by specifying these dependencies and outputs, in terms of actual dependencies and outputs, here are files, some files that we use as an input for the stage, or that are generated by the stage. And parameters is just some parameters from other files. And when we write this configuration file, like, first of all, it's quite easy to understand what is happening inside the project itself when you read such kind of configuration file. And then DVC uses these dependencies and outputs between stages to understand the order to run the pipeline itself. Okay, so for example, and by result, like we are talking about like experiment management, so experiment versioning. Sorry, so we not only version that the data and code itself, but by tracking like dependencies in our experiments and metrics as a result, we can talk about experiment versioning. And let me come back to that first example. So that example gets started that we actually started with, and open this dvc.yaml file specific for this example. And inside, we see this artifact stage. We'll talk about this a bit later. But here we see the stages. So that couple of stages, and for the prepare stage, we have we call this src prepare.py script that takes original data sets and do some kind of cleaning and preparation for that. And like, here's the command, here's the dependencies. We need this file with data that we just downloaded with DVC-get. Then we can specify the script itself. The idea here that every time you run the new experiment with DVC, DVC can check the changes in their dependencies. So if you specify, for example, the script file itself here as a dependency, DVC will track any changes inside that code. If you change some, I don't know, some function, whatever inside this file, DVC will detect it and understand that, like, since the previous run, something happened in the dependencies, and it need to rerun the stage again. And as output, we like have some prepared data set. And also that to configure the stage, DVC uses some parameters. And for parameters in DVC is also some YAML file that there is no like specific structure inside, but it's like pretty useful to have maybe some like common or global parameters, I would say, like a seed or like a split, whatever, I don't know. And it's can be useful to keep parameters for separate stages in like under some like name of the stage. Like here is parameters for featureized stage, and this for train, right? And inside this dvc.yaml file, we later can just call this, let DVC know that for this prepare stage, it should care about versions of parameters in this prepare section in params.yaml file. Params.yaml file is the name of the parameter files by default. You can change it, but like by default, it just trying to find this this seed parameter and the prepare section in params.yaml file. Okay, so if you change this split, for example, to other value, so DVC will detect this. And this is actually like example how DVC, how you can configure your pipeline, and like later DVC will understand that in which order it should run, and will track all versions of them. Okay, and as soon as we have it and we downloaded all data sets, we can just run the new experiment with a simple DVC exp run command. Okay, and here is a good example, good one. So I just run DVC exp run command, and I see that like it completed in a few seconds, and we see that DVC told us that nothing changing, like stage didn't change, and it skipped it. So when you try to run this pipeline, DVC will see on all dependencies inside your dvc.yaml file for every step, like this one. Okay, and if and compare the versions of data and the script with a previous one that committed, and see that nothing changed, so it just keep running the stage. And this is like a pretty good behavior in many cases, because, for example, if data preparation takes a couple of hours, so you don't want usually to run it every time, right? You can just run this preparation step once, and then experiment with features and different hyperparameters, whatever, algorithms. And so this behavior is like pretty useful to speed up the experimentation process. But if we will open a parameter file, and let's say we want to split like not 20 but 30%, so, and we run it again, DVC will detect this change and will rerun the whole pipeline starting with this prepare stage. So it will take some time to run the all stages, and we can just come back to that to the presentation, and I'll show you the couple of commands that can be useful as well. So we used only this DVC exp run command that just take our dvc.yaml configuration for the pipeline, take parameters from params.yaml file and run it. But we can do it like from the command line, we can change parameters for that pipeline. So with set parameters or like big S, we can specify like, for example, some parameter, and DVC will update this parameter inside params.yaml file first, and then run experiment with that new params.yaml file. Okay, so okay, let's just try it. We can use -s. We can use prepare split and set it to 0.4. Okay, you see it's updated here. So DVC updated this configuration, and then we run the experiment again. And after the experiment complete, you can see that the git status that something happens. So we see the changes in param.yaml file and DVC log file. And yeah, and DVC should also detect some changes in. No, nothing changed. Okay. That's it. That's it then. Let's continue. So this is how you can run experiments and run pipelines. And because like you have different parameters and metrics for your experiments, like you may be interested in the tracking DVC experiments, experiments itself. So we are not talking about all the pipelines, how to run pipelines. We already like solved this, but we want to track like experiments. And we also can do this easily with DVC XP show command, so from command line. And DVC will show us a few entries here. Actually, those entries are like the first version for the main branch here is the version of the state for our project for the main branch that we for the repository we cloned here, and all other entries here are our runs that we use to run when we rerun experiment. Okay, and it's like in some use cases it's handy to see the results in command line interface. Sometimes not. When you run like it locally, we have additional tool called DVC extension for VSCode. If you work with VSCode for your experiments, you can use this interface also to check metrics, parameters, and different states of your experiment. You can show plots and visualize some results for your experiments here in the same in VS Code extension. And like this is like next question, how to specify those metrics and parameters, right? So to do this, we have a additional, like first we had these stages that help you to specify steps in your pipeline, right, with dependencies and outputs. And you also can specify metrics and plots that you use to track metrics for your experiments. So in this case, what we have here, so let's open eval subdirectory, and inside we see this metrics file and plots that are like so actually this is a subdirectory where DVC expects to find files to and visualize as a metrics or plots. And to save this plots files, we use we have an additional Python API, so with DVCLive that help to save metrics and plots in the simple way from your Python code. So DVCLive actually is a Python specific. So you can like there are two options how you can save, for example, metrics and track them with DVC in command line or VS Code extension. You can save metrics in the formats that DVC understands. So it's like JSON or CSV into files using any tool. Just save them and they should look like this, and specifying DVC.yaml file. Or for Python projects, so it's much handy to use this library DVCLive, and in this case you just use okay, so it's a function with some code inside. The function that calculates some metrics, but there are like a couple of methods in this DVCLive library that can log plots and metrics for machine learning projects. So there are couple of them. Yep, and yeah, and this is actually how you can run like multiple experiments, track results of those experiments, and if you want to like save the some experiment to like right now we run all these 3 experiments locally, right? We run 3 experiments locally, but if you want to and those experiments, the results of the all experiments, they are stored in some like hidden place under the Git repo .git directory for your repository. But what you can do actually, you can create. I close this one. You can convert some experiment into like branch, and to make it like real like committed results of that experiment to the project, the repository. For this, you can just take DVC exp, create branch, and use this code for the run that you want to convert into the branch. And now we can see that a new branch is created, git branch. So we have this new branch. We can like check out to that branch. We can push it to the Git repository. We can merge that branch to the main, do whatever we want with that branch. And now we'll see that this is like after that, we preserve results of the experiment to the Git history. Okay. So this helps us to like treat all our machine learning experiments and results as a code, link experiments to the Git repository, and use Git repository as a source of truth for all operations with machine learning project. So, and yeah, we already talked with DVCLive that it can log just simple metrics, it can log scikit-learn plots, it can log parameters, so whatever, and like save them in some clear standardized directory that is easy to read by VSCode extension for DVC, or commit to the Git repository itself and visualize later. You can also do it inside Jupyter notebooks. You can like automatically run it, and for this you can follow this example. Also, let me share the link with you. You may be interested in this. So the idea is like that you can use DVCLive and start using, get benefits of DVC by using Jupyter Notebook. So here is like results of, examples of code, how to track those results inside Jupyter Notebooks. And like when you run it, you'll see that just inside Jupyter Notebooks, you'll see those plots and metrics updated in real time. And if it's, it can be like what you need actually when you work with prototypes. Okay. So that's it with pipelines and metrics tracking. We were working with, I see the question with VSCode. So the IDE I show is VSCode, and for VSCode, you can find like free plugin DVC extension that you can install and to visualize and track results of your pipelines. Yeah, and okay, so we completed with pipelines. You can, with DVC, you can have I show you the pipelines in this example is the like monolithic pipeline, I would say, for the for this experimentation stage, right? So we have the steps that prepare data. We can steps that train model and evaluate model. For training, we have these outputs. In outs, we have our model file that automatically versioned with DVC. Like when we discussed DVC version part, we were talking about like how you can add some standalone file and DVC version control. But when you use DVC pipelines, whatever you specify in outs can be automatically tracked by DVC. So actually it's automatically tracked with DVC. If, for example, you don't want to version it with file and want to keep it under that Git version control, you just specify that cache false. It means that DVC will not store this file into DVC cache, and file will be versioned with Git, and you'll track it and find it in Git. It's like works pretty well for small files like metrics, plots, for small models. So it's you don't need actually remote storage and keep that file there. But for neural networks, for big files, of course, DVC can help by uploading that file to remote storage. Okay. So, and when we have that models as outputs, and they are versioned already, they are linked to the Git, everything's fine. So we can think about how to work with models and how to build some kind of model registry for these models and to manage different versions of models and to use them in production. We have a separate tool. We will not like spend more time on that. The tool is called GTO, or Git Tags Operations, and we have like we use these tools to create some specific Git tags for the models, and it works like you have the model file that is tracked with DVC, and we save that file into the remote data storage, and we keep metadata in our Git repository, and everything's fine. And GTO just adds some tags, specific tags that is easy to help to simplify like managing the stages of your models. For example, you can create different stages for you, like development, production, test, whatever, and you can register a new version of the model to using GTO. And when you do it, like GTO, like register model file, GTO will create specific Git tags for your model and will push the tags to your Git repository. And it will help like to, for example, it can be used for CI/CD pipelines to detect that new Git tag with a specific format created for your model. And this can be a signal to run deployment pipelines and like update your model in production. Sounds like that. Or also you can, it can help to download the models during that CI/CD pipeline. For example, for your production system, it can take the version of the model and download it using DVC or some other tools to download a file itself. Okay, and this is like additional scenario that DVC can bring to production pipelines using CI/CD configuration. So in this case, we have like example of a simple CI/CD pipeline where like first we create some deploy runner using CML, another open source tool, that some kind of wrapper on Terraform, on top of Terraform, that can launch new instances in clouds, do some kind of provisioning, and after your experiment complete, can create the pull request with updates back to your Git repository. But here we'll focus on that, how to use DVC in CI/CD pipeline. First, what we can do is we can automate training pipelines using CI/CD. For example, when you I don't know, update your code and create pull request into the main branch. So this event can trigger the CI pipeline that will first launch a new runner and allocate some resources for training process. Then the train model job that will actually do a few steps, and we already know how to. What does it mean? It will pull the initial data set for the project using DVC pool. Then it will run the new experiment using DVC exp run, and after that it will push the results of the experiment to the remote storage using DVC push command. And also you can extract some metrics and parameters reports from that experiment and like publish it to the commit as a comment to your PR or whatever. So this is just simple scenario, right? How DVC can be used for this CI/CD pipeline, but they can be like there are multiple options what you can do for CI pipeline. It's a common use case when people run the training as a part of CI pipeline, and after that they can register the model to model registry and keep it in some storage using DVC and GTO. And when we go to the delivery pipeline, CD pipeline, so that jobs can access the specific version of the model using Git tags, and then download that model with DVC, for example, and deploy model in whatever like system you use. So this is like CI CD configuration. This is how you can set up DevOps approach. What I can show you here, let me check. Yeah, let me just open, give you some, yeah, just open this example from the studio. Yeah, I guess we have some, yeah, this is example of Git tag generated by GTO for model like trained with DVC. So we just like specific format of the tag that attach to the specific commit in your Git history. And we can use this tag to understand for what commit in the Git history we can find that the model, I don't know, trained for our product that we used in production, for example. So I'll show a bit later that interface, just to let you know how it can look like. But we can talk about the monitoring step. So we covered data management, training pipeline, and like, let's say you have some kind of inference pipeline, and for inference you can download model using DVC, and we can talk about monitoring part, right? As soon as you run experiment, you run the model and it generates predictions, you'll need to some kind of tools to monitoring. So there are different tools, of course, right, and for different purposes. And here I have some simple example for monitoring pipelines, not the monitoring the model itself, because usually like it's a separate standalone pipeline that just take the predictions, take the ground truth data, calculate some monitor metrics, do reports, and visualize them with in Grafana or I don't know, some other dashboarding tool for monitoring. But like here is an example how you can integrate monitoring with DVC pipelines, specifically for monitoring data and like visualizing some reports. And there is evidently the library evidently AI that can be used to different monitoring use cases. And we can use these tools together. For example, for generating model performance reports and monitoring data and target drifts. So what is like evidently does, it just takes some reference data set that and like new data set and compare them, calculate some kind of metrics to understand whether the distributions and some specific parameters of the data sets are same and different. And this helps to detect some drifts in data and target variable and somehow visualize to give you some information about it. And like when to make it work actually for the new data set, you need to save those and manage those reference data sets, and they can be versioned. Actually, they should be versioned and attached to the Git repository as well. And also you'll have these reports, nice reports in HTML formats that you also can manage with DVC. You don't need like much like it from the versioning perspective. It's not so important as versions of data and models, but for visualization point of view, for collaboration, it can be handy to keep those ready to use HTML versions and visualize them. I don't have this example here, but yeah, unfortunately, we don't have time to run it. But here's the idea how those reports can look like. And here's also example of that you may look into later with how it will look like. But the idea is just we at the training stage it generates some reference data set, and we like version it with DVC. And at for the monitoring job, it take that reference data sets, calculate some metrics, generate report, and those reports will also track with DVC. So this can be like handy for many use cases. Yeah. So please, if you have any questions regarding pipelines, regarding some DVC tools, scenarios, whatever, so any questions you have, please put your question to the Q&A channel, and I'm happy to answer. And we have some time to that I want to show you the studio, DVC Studio, as an example of GitOps-based platform for machine learning projects, because the studio is based on the DVC, GTO, and other open source tools that you can like we provide studio as a service, right, paid service. But this is example how those tools can be integrated together in different extent, if you like, using simple interfaces, for example, like a Streamlit or something similar. But you can just to give you an idea how they can work together. Okay, so what is a studio? For the studio, like we just unify experience of data scientists that they have when they run experiments on local machine or on a remote cluster. So we just like bring everything together in one simple interface and provide like visualization for the parameters and metrics and data changes for your experiments that like linked to the Git history. So you can organize your experiment into separate branches. So you can have a separate branch for some specific algorithm, for example, you use or model, neural model architecture for your experiment. and you can run a lot of experiments inside those branch. And after it completes, you can merge it to the main branch for the production use. Yeah, so we can Studio show this parameters and metrics. You can like adjust the visualization of the experiment table and show plots for your experiments. And of course, you can compare experiments, not just for example, when you use like metrics tracking experiments tracking tools like MLflow and some others, they don't link to your experiment to some Git revision, to Git branch. It means that sometimes you don't need what exactly versions of data and parameters you use to run that version of code. But because DVC link all this information together using Git repositories, so every experiment here, every line here, and plots and metrics, they are aligned with the Git history, and you can easily understand and restore the versions of files and artifacts that they use for these experiments. Yeah, and also from the Studio UI, you can click the Run button, update some parameters from param.yaml file, and just click Commit Changes. That will create the new commit on new branch, new Git repository, and automatically run new experiment with new parameters. And this is how what Studio brings. Just a couple of examples here for this experiment. So this is how it looked like. We can take some minor updates to make it work from the Studio UI. You need to have some some additional configuration using CML and CI/CD, but it's not you just need to do it once to make it work. So you just change, you commit, and DVC Studio will create the new branch like you see here, and it will run new experiment in the background. And after it complete, it will bring the results here. But beside that, you can see, you can select a couple of experiments and visualize results here. So it's plots, it's images with some masks. So it can be different kind of information you can see here. And also, if we open it, we can, for example, filter out experiments with models registered for that experiments. So we can have the models with specific versions, or some it's version 2, the models that we registered, and they started with version 2. So we can see those versions here for the models, and we can navigate to models itself. Just so inside Studio, we have model registry that aggregate information about models around your projects. And if you open that model, you can see the information about creation of that model, who created that model, when, how it was changed, what passed to the model file. You can access the model and download it using different ways, like Python API, just download this file, whatever. So there are different options. You can see attached metrics and parameters and plots and whatever you like. So, and when, for example, you register new version, or you assigned model to the new stage, like you can assign it to the demo stage, for example, whatever you like. So you can create the stage you want. What Studio does, it actually under the hood uses GTO to create some specific metric for that model. And yeah, and you see we have the new specific stage for this model and like new new tag added to that model. We can open that model in Git repository, for example. Let's open it. Navigate to the tags, and we'll see that new tag has created for this stage. This stage, like demo, we can call this stage as some environment. It can be production, demo, development environment. And as soon as we assign this new stage, the new pipeline, CI pipeline triggered, and now it's running, and it's open. So it will definitely crash now because it's not like set up to run jobs in the cloud because of I didn't provide that credentials to do this. But if we'll like navigate inside the configuration for this pipeline, just as for example, I'll show you this GitLab CI configuration with a couple of jobs that, yeah, it like first deploy the runner itself that will manage cloud instances, and it only need to update these credentials. And after it will run the job. So in this case, it will do some kind of retraining, or it can be like deploying like inference jobs or whatever, or updating the model at the in the production system that use model to run the inference to generate prediction, sounds like that. Yes, and okay. Yeah, this is actually how it works. So new tag, and using GitLab or GitHub CI, you can detect that new tag created. This, for example, this tag is specific for some environment, for demo environment, or we have somewhere here some for development or production environment. And this is how you can like automate the whole CI/CD pipeline for your project. Okay, I guess that's it from my side. So I'm happy to answer your questions. Please feel free to post your question to Q&A channel, and we have time to answer it, I guess. Anyway, if you have like any question or you want to discuss any of this during the conference, so please find me, pin me on LinkedIn, or find me during the conference days, and I'll be happy to talk with you and help you with some of these tools or questions around like integrating DVC tools with other tools. With different tools to track experiments, tools that can schedule jobs like Airflow, Ray, or whatever. So any kind of question that you might have, I'm happy to help with. So please keep updated, and please connect me on LinkedIn and let me know if you have any questions. Okay, so please share any question to Q&A channel, if you have. Seems we don't have questions.
Okay, if you don't have any questions, thank you, Mikhail, for the tutorial, and thank you everyone for